Okay, let's wrap up this unit. Quick small unit. So we're going on to example number 3. The mass of the moon is 7.3 times 10 to the 22nd kilograms, and its radius is 1,785 kilometers. What is the strength of the gravitational field on the surface of the moon? Now, I want you to notice these kinds of questions, and we can refer back to number 1 as well. There's a lot of changing of prefixes. We need to bring it back to those SI units that we want it to be. So instead of kilometers, we want meters. So there's 1,000 meters in 1 kilometer. So this would be, okay, we have that many meters. Let's see if we can get this to focus a little bit better. That's probably where we're at. Okay. And so then the strength of the gravitational field, that force due to gravity, and we're going to simplify this. We know the mass of the moon. What if we just see what that would be? That force would be on a 1 kilogram object. So we have the mass of the moon, we have a 1 kilogram object, we have the radius of the moon, and remember when we calculated the weight of the Earth, and we said that the Earth is so big that whatever tiny object that's on it, it's essentially the same as the radius of the Earth. Same concept here with the moon. Okay, so we know. Let's list what we know. Mass of the moon, 7.3. Mass of the object, 1 kilogram. Radius 1,785 thousand meters. Okay, and then we know that our constant there is 6.67 times 10 to the negative 11. Oh, not 111, just 11 Newton meters squared per kilogram squared. So that force is going to equal G times by mass of the moon times by mass 1 divided by R squared. Okay, so we have 6.67 times by 10 to the negative 11 multiplied by the whole thing, and on the top we have another number in scientific notation. I don't think it's necessary, but just to make sure, I'm going to put another set of parentheses in there. So it'll be 7.3 times by 10 to the 22nd, and multiplying that by 1 divided by, and then what's on the bottom, we have our radius, 178 squared. Okay, and then I'm checking with my pretty print. I have those two multiplied together, squared. Okay, so that force is 1.2663, so 1.5 newtons. Okay, and then example number 4. Bob has a mass of 70 kilograms, and Ingrid has a mass of 50 kilograms. Bob and Ingrid are standing 20 meters apart in the commons. Ingrid looks up, sees Bob, feels an attraction. If the attraction is only gravitational, find the size. Okay, so what do we know? We know that mass 1 of Bob is 70 kilograms. Mass 2 of Ingrid is 50 kilograms. We know that the distance between them is 20 meters. And we know that the constant, gravitational constant there is 6.67 times 10 to the negative 11 Newton meters squared per kilogram. And we have our equation to figure out that force due to gravity. So it's going to be G multiplied by M1, M2, R squared. Okay. Since I've done an equation recently, I'm just going to cursor up and grab it. And let's see, our new R value is 20 meters. And then we have the mass of 50, mass of 70. Okay, and then we're checking that pretty print there. Okay, look at how tiny that is. So 3 sig figs, 3 sig figs, 3 sig figs. So 5.84 times 10 to the negative 10 newtons. Okay, awesome. So we have our concept check and our assignment for gravity, and then anticipate that next week you'll have your review and then your first exam for this quarter. Alright guys, if you have any questions at all, please send me an email and I'll get right back to you.